All right. One thing that you're going to have to do in calculus that you may not have had to do in a math class before is actually look at the book once in a while. There's enough theorems, there's enough examples in the book that sometimes I'm just going to say, hey, there's this really important thing on page 22. You need to make sure you look at it. Again, because we don't have time to copy the book into our notes. So keep your book handy. And in my notes, when I say see page 22, I actually want you to see page 22. There's something on there that I really want you to see. First thing we need to talk about is basic types of graphs. Yes, you're going to have a graphing calculator, but you have to be smarter than your graphing calculator. Your graphing calculator is faster than you, but it's not smarter than you. If you think that you've typed 2 plus 3 and you get an answer of 6, you don't just write down 6. You go, whoa, that can't be right. And you need to do the very same thing with graphs. You need to know the basic graphs well enough that if you graph x squared minus 3 and it turns out to be a straight line, you go, whoa, something's wrong. That's not supposed to be a straight line. So sometimes it's just a matter of the window that you're using when you graph. Sometimes something looks like a straight line, but you know it's not supposed to be a straight line. When you zoom out from it, you can see that it's not a straight line. But again, if you don't know to begin with what it's supposed to look like, then you're not going to know when either you've made a typo or you need to change your graphing window on your calculator. So today, I'm hoping it's boring. That's the goal for today. Today, you're supposed to know everything. Because I didn't know how much time we had, I typed some ridiculous stuff down here. I typed steps for finding intercepts. So you don't have to write much today. I just didn't know how much time we'd have, so I typed everything. On page 22 of the text, you do have the basic graphs that as soon as you see those equations, you should immediately know that if you have a linear equation, it's going to give you a straight line. Now, how do you recognize a linear equation? What causes me to go, hey, this equation's linear? That is a test to see if something's a function. That is an important thing, but it's not how you tell if an equation is linear or if you graph it, how you know it's going to be a straight line. What does the word linear mean? Lynn, you know?
It has a constant slope.
Say that one more time.
It has a constant slope.
I like that. That wasn't what I was expecting, but you're exactly right. If it has a constant slope, if your rise over run is the exact same ratio from any one point to another point, then it's going to be a line, absolutely. There's one other thing. As opposed to quadratic, how do you know something's going to be linear? And y to the first. A first degree equation. That's what a linear equation means. If it's a first degree equation, then its graph is going to be a straight line, and you should know everything about graphing straight lines. Second degree equations, what's that keyword for a second degree equation? Quadratic equations are U-shaped graphs. Parabolas come from quadratic equations. Cubing, the cubing function, y equals x cubed, is kind of snake-shaped. And cube root of x, they don't have on here, but cube root of x would be that snake-shaped turn sideways. So I call the cubing function a vertical snake, and then cube root of x is a horizontal snake. Let's get back on the handout for a second. I've mentioned linear equations, quadratic equations, cubic equations. Absolute value equations have V-shaped graphs. Every once in a while, I have to say, technically, that's not true, not always true. This would be a little bit better known if I said, oh, I did say it. Absolute value of a linear expression. You have absolute value of a first degree expression. That's going to be a V-shaped. If you put an x square inside the absolute value, it's not going to be a V-shape, it's going to be something else. But as long as you have an absolute value inside that V-shape, or inside that absolute value, it's going to be a V-shaped graph. Specifically, this V has been shifted how? Up, down, left, or right? To the right, 2 units. So all I need to have in my head, I know my calculator is going to graph for me, but the quick mental image I need to have in my head is just a V shape that's been shifted 2 to the right. If that is what pops up on the calculator, then I know I can trust it. But I certainly don't want to have to make a big XY chart to figure that out. I just need to know that's a V shape that's been shifted 2 places to the right. Y equals the square root of x minus h plus k. This is a graph that has been shifted horizontally h units, either to the left or to the right, h units, and up or down k units. But if you have square root of x plus something or x minus something, that's going to be a half a parabola. And this is a half a parabola that's been shifted how? 2 units to the right again, just like this. Whatever kind of function we have, a squaring, a cubing, a cube rooting, an absolute valuing function, if something's added or subtracted inside the parenthesis or inside the absolute value or under the radical, that's your horizontal shift. And that horizontal shift always works the opposite of what you might have expected. Subtracting 2 actually moves the graph to the right 2. Here, subtracting 2 is going to move that graph to the right 2. Whatever's added or subtracted on the end, outside the radical or outside the absolute value, that's your vertical shift, and it works like you expect it to. Adding moves the graph up, subtracting moves it down. So square root of x minus 2, the quick mental image that I need to have in my head is just, that's half a parabola shifted 2 places to the right. Ooh, for 4,000 bonus points. And you don't have to come back. 4,000 points is enough. What would give me the bottom half of that parabola? That would give me the whole parabola if I had plus or minus. Would a whole sideways parabola be a function? And that's where your vertical line test comes in. You were just ahead of your time. If I had a whole sideways parabola, it wouldn't pass the vertical line test. It wouldn't be a function, but change your answer a tiny bit and just tell me what would give me only the bottom half of that function. A minus in front of the radical. Just like y equals x squared is a concave up parabola, you put a negative coefficient on it, you get a concave down parabola. You don't have to come back, by the way. You can just hang out in the library the rest of the semester. All right. An equation which yields the graph of a circle. Notice that in that equation, both the x and the y are squared. If you FOIL that all out and got it set equal to 0 to have it in what's called standard form or general form, you'd have an x squared and a y squared. That x and y both being squared with the same positive coefficient is what gives you a circle. So when I look at this example, x minus 3 squared plus y plus 2 squared equals 25, I think, hey, both variables are squared, same positive coefficient. What is the positive coefficient? 1. So it's a circle with center opposite of both of those guys, positive 3, negative 2, and radius what? Radius is square root of that constant on the right-hand side. So that gives you a circle. The only other one that I felt like mentioning, no, 2 others that I felt like mentioning this morning, if we take this equation of a circle and we solve for either x or y, then we can get the equation of semicircles. Now, if I had a whole circle and I found the equation that gave me the left-hand side, would the left-hand side of that semicircle be a function? Wouldn't pass the vertical line test. Will the right-hand side be a function? No. Would just the top be a function?
Yeah.
Yes, and just the bottom would be a function. So if you solve the equation of a circle for y, and you have y equals plus or minus, and then something minus x squared, if you square both sides of that equation, you'll get the whole circle. But if you just solve for y and take just the plus or just the minus, you'll have a semicircle. All right, let me write something right here. If I take that equation in part G and I square both sides, if I square both sides, I'd have y squared equals, what happens when you square that negative? What happens when you square a negative? You get a positive. What happens when I square the square root of 4 minus x squared? The square and the square root undo each other. So I have that. And then when I add x squared to both sides, I recognize that as the equation of a circle. It's a circle with center what? 0, 0, because nothing's subtracted from the x, nothing subtracted from the y before you square it. And radius what? 2. Radius 2. So this original equation is half of that graph. If y is negative square root of something, that means y is always negative. Would that be the top half of the circle or the bottom half of the circle where the y is always negative? Bottom half of that circle. So bottom half of a circle with center 0, 0 and radius 2. And that is a function because it passes the vertical line test. A graph that I don't believe was mentioned on page 22 is the rational function 1 over x. Can you show me with your hands what you know the graph of 1 over x looks like? It's going to take 2 hands. Kind of like that, with me being the y-axis. What's that word for what you call the x-axis when the graph gets closer and closer to it? It's an asymptote. The x-axis is a horizontal asymptote. Horizontal because it's lying this way. An asymptote because the graph's going to get closer and closer to it as x goes forever to the left or forever to the right. And then the y-axis is a vertical asymptote. You think about squaring numbers that get closer and closer to, I don't mean squaring numbers, I mean flipping numbers, 1 over x, taking the reciprocals of fractions getting closer and closer to 0. If you flip a half, you get what? 2. If you flip a third, you get 3. If you flip a tenth, you get 10. And if you flip 100, you get 100. So as x gets closer and closer to 0 from the right, what's happening to your y's? Where are they going? They're getting infinitely big. They're going to infinity. Now, this is some notation that you may have seen in some algebra book. You may have not seen in an algebra book. I don't know if you've seen that notation before or not. But this third one is the shorthand way of saying what we just figured out. This little plus up in the air means x approaches 0 from the right. So x approaches 0 from the right is moving in this way And we can see as x approaches 0 from the right, my y's are going to infinity. Who could read this notation for me as x what? Approaches 0 from the left. Put your pencil on the graph and say, as x approaches 0 from the left, what would you say about y? Infinitely small is y's are going to negative infinity. And that's actually the definition of a horizontal asymptote. A line is a horizontal asymptote if, as x goes to either, I may be saying that wrong, what do you think? I am saying that wrong. Wipe that out for a second, I'll come back to it. What about these two? As x goes to infinity, as x gets bigger and bigger and bigger, what's happening to your y's? They're getting closer and closer to 0. And as your x's approach negative infinity, or as your x's go forever to the left, what are your y's getting close to? 0. That's your definition of a horizontal asymptote. A horizontal, and you don't have to write this down because we're going to talk more about it later, but if as x goes either forever to the right or forever to the left, there's some number that y is getting close to, then y equals that number is the horizontal asymptote. And here is y equals 0. I don't know if you all have a graphing calculator with you today, or you may be totally comfortable using a graphing calculator. If you have one, pull it out and let's graph this real quick. Y equals 10 over x squared plus 1. If you don't have a graphing calculator today, that's fine. Just get it in the next week or so and you'll be all right. Let's see. To graph something on a TI 83 or 84, and this is the one that I can display on the board. I have that on my desktop. Here's your y equals where you enter functions, and when you need to enter a variable and x, use this xt theta n key that types your variables. So y equals, clear out stuff I had from a previous life. 10 divided by, there's my x, there's my square, plus 1. Is that going to give me the correct graph for what I have typed on the paper? What's wrong with that? If I want to override the order of operations, when my calculator sees this, my calculator is programmed to know to do division before addition. If I want to override that, then I have to put the whole expression I want to divide by in the denominator. I have to put it in parentheses. So just wanted to make sure you knew that. And I can go back and insert a left parenthesis and a right parenthesis. That should give me the right graph. I don't know what window I last used on this calculator. So if I just say graph, no telling square my, that looks pretty standard. Okay, I didn't have anything weird on there. Holy cow, what's up with that? Is this something my my calculator just can't handle? There's not much my calculator can't handle. What do you think? Yeah. I think I'm going to have to zoom out. It looks like that window, if my tick marks are counting by ones, then my window only goes from -5 to 5 on both windows, or on both axes. If I want to manually set the window to what I want it to be, I can use my window key. If I just want to go to the default window, which for TI is -10 to 10 on both axes, I can press zoom. And number 6 says zoom standard. Does that graph make sense for this equation? This equation is 10 over x squared plus 1. Does that graph make sense for that equation? Yes. That was an easy thing to guess, but why? Tell me why I should have expected to only have portions of this graph in the first and the second quadrant and nothing in the third and fourth quadrant. What caused that?
X squared, you square a negative, it becomes a positive.
No matter what you let x be, this denominator is going to be positive. Even if you let x be 0, the denominator is going to be positive. If you let x be positive, if you let x be negative, that's always positive. Since the numerator is positive, this is always going to be a positive divided by a positive. And a positive divided by a positive is a, and that's why you only have pieces of the graph in the first and second quadrant. It makes sense that as x's get bigger and bigger, what happens to a fraction as its denominator gets bigger and bigger? The whole thing gets smaller. You start dividing 10 into more and more and more pieces, the pieces are going to get smaller and smaller. And that's why you have horizontal asymptote of the x-axis in both directions. So when you're graphing, always take just a second and go, does that graph make sense? If it's not one of the things that I have memorized, like the linear equation, quadratic equation, the absolute value equation, go ahead and use your calculator, but stop and think, does that make sense before you just automatically trust it? All right, here's where I knew, let's see, put that there. Here's where I knew we would start running out of time. So I started typing everything that normally I would not type. I'd let you figure it out. But make sure that you understand how to find the intercepts of a graph. For any graph, you can find the x and y intercepts. What is always true about the x-intercepts, where the graph crosses the x-axis? Y is 0. If you're sitting on the x-axis, y is 0. And what is always true about any point on the y-axis? X is 0. That's why when you have an equation, if you want to find the y-intercepts, let x be 0. If you want to find the x-intercept, let y be 0. It's usually easier to find the y-intercepts. It's usually pretty darn easy to plug the 0 in for x. That y-intercept is 0. Those x-intercepts, this is a fraction. What makes a fraction equal 0? What's the only way a fraction can equal 0? If it has 0 in the numerator and something else in the denominator. So if we're looking for what makes it 0, we need to only find what makes the numerator 0. And we can find that by factoring. Turns out that this has 2 x-intercepts, 0, -3. Now this particular example had 2 x-intercepts and 1 y-intercept. Is that always going to be the case? Certainly not. Could we ever have just 1 x-intercept and 2 y-intercepts if we're graphing a function? If I hadn't put that, if we're graphing a function on there, then yeah, I mean, we can have a graph that has lots of y-intercepts, but it's not a function. If you have a function, it can have at most y-intercept. one y-intercept. Is there a way it could have no y-intercept? Yeah. Tell me what a graph could look like that had no y-intercept. It could just be a vertical line. That has no y-intercept.
Square root of x minus 2.
Ooh. Well, x minus 2, yes, you're right. Because that's been shifted 2 to the right, and that doesn't have a y-intercept. All right, we can't have more than one y-intercept. How are we doing? We have 7 more minutes. All right. Number 26 is another one that I'm not going to talk you through it because I typed the whole problem and typed the words out beside it telling you what I did in each step. But in general, any odd problem that I think might be challenging in the homework, I usually do the even problem right beside it as an example so that you can follow that example if you need to. If you get stuck on either number 25 or number 27 in the homework, there's a good chance that it looks pretty much like that and you can follow those steps. Number 54, we're not going to take time to do this because we're running out of time, but what causes me to think, hey, that could possibly be a circle? The x and the y are both squared. I'm thinking that might be a circle. What makes me know it's not a circle, though? Not the same coefficients. We haven't gone the same distance left and right as we did up and down. Did you think calculus started at 9? You did? Surprise! Hang around afterwards. I'll give you the syllabus and stuff. All right, you know now. It's okay. You can't enter this. This is actually an ellipse, but you can't enter it in this form on your calculator. You have to solve it for y to be able to graph it on your calculator. When you solve for y, you're going to get a plus or minus, and then you can enter it as 2 equations. You can enter y equals square root of 1 minus 0.25x squared. You can let that be y1. Positive square root of blah, blah, blah. You can actually type it in again for y2, negative square root of blah, blah, blah. Or you can say y2 is negative y1. And that'll give you the top half of the ellipse and the bottom half of the ellipse. I'd have to play with buttons for just a minute to remember where to get to that y1. I think it's under bears, but I have to look for it. All right. The last thing no, 2 more things. Roman numerals 3 and 4. The next to last thing you have to do in the homework is find the intersection of 2 graphs. That's going to be important in calculus. If I have 2 graphs of the form y equals something something. If, for example, I have y equals 4, that's just a horizontal line through 4, and I have y equals x squared minus 2, that's a parabola. If I want to know where they intersect, that's where y is the same thing, then I can just set these 2 right-hand expressions equal to each other. That's when y will be the same thing, when 4 equals x squared minus 2. And then I can solve for x. And that's exactly what I did here. Find the points of intersection for x equals 3 minus y squared and y equals x squared minus 1. I just said, well, if y is the same thing as x minus 1, I can put x minus 1 in place of that y and solve for x. That'll give me the 2 x values that are points of intersection, 2 and negative 1. Where did I get those 2 y values? Just resubstitute. If x equals 2, then y is 2 minus 1. If x is negative 1, y is negative 1 minus 1.
It's just like a system.
Yeah, you're just solving a system of equations. This example, I told you how to punch it on the calculator. We don't have time to go through that, but you can read it if you're not sure how to find the point of intersection on a graph. Last thing I want to mention, and I'll give you these notes in just a second. Last thing I want to mention is if I tell you something is a linear equation, and I give you a point and a slope, you can plug it in point-slope form and find the equation of the line. If I give you 2 points, you can find the slope, and then you can find the equation of the line. But what if I tell you something's not linear, and I just give you its x-intercepts? Remind me again how you find the x-intercepts? You let y be 0. So if I have an x-intercept at 4, what factor, what equation, or what expression, if I set it equal to 0, would give me 4 as a solution? X minus 4. If I set x minus 4 equal to 0, then I get the x-intercept 4. If I set, what expression set equal to 0 would give me negative 3 halves as a solution? X plus 3 halves. So if x equals negative 3 halves is an intercept, then x minus 3 halves, plus, you told me that, I wrote it down wrong. X plus 3 halves is one of the factors. And if 4 is one of the x-intercepts, then x minus 4 is one of the factors. And if one of the x-intercepts is 5 halves, then x minus 5 halves is one of the factors. One other thing. Why did this say find an equation instead of find the equation? How could there be other answers, other equations that had these 3 x-intercepts? Another 4,000 bonus points and somebody else doesn't have to come back. You already don't have to come back.
Add a constant coefficient to each term.
You could change that coefficient. Awesome. Y'all just already smart. I'm kidding. You both be here tomorrow. Put a coefficient on there, and it will compress it or expand it or maybe flip upside down, but it wouldn't change the x-intercepts. All right, here's the homework. These few right here, you only have to graph them no matter what A, B, C, D are in the book. If you don't have the book, very important, I put the chapter 1 homework in Momentum, especially for folks who didn't have the book today. So you can do the homework even if you don't have your book. It's in Momentum, and you need to bring the 1.2 notes with you tomorrow. All right, see ya. All right, let me give you what you missed real quickly. A syllabus, that, and that. All right, okay, you do something like that for example. You are, double check. Where did I put my rule?